Hello, folks. My name is DC Rockwell, and this is your co-host, Elio Greco. Welcome to Code and Chaos, a pseudo-random conversation that starts with tech and ends where it ends, an hour or two later. Tonight, we have a special guest, Alan Woods. Elio, would you like to introduce our special guest?
Yeah, thank you. So I've met a ton of interesting people on LinkedIn, and some people I keep seeing posts and I keep seeing replies, and I'm like, wow, that's really interesting. That's an interesting angle. That's a really insightful comment. And so Alan was one of those people, and then I started paying more attention and chatted with him, and I'm like, oh wow, he's studied cybernetics. He's got a really good understanding of how systems work and how programming should work versus how it does work and various other things. So reached out and said, I'd love to talk more about this, actually talk about it on the show. So here he is. And if you want to give us some more background, you have quite the history, Alan.
Well, first of all, thanks for inviting me on to do this. I have an idea, like I said just 2 minutes ago, you're going to be telling me to shut up after about 5 minutes, but that's just the way it goes. Just a brief summary. What I tend to do is ask people to look me up on LinkedIn and have a look at my bio there. It's my strapline is "How the hell did that happen?" which just about sums up my life. I joined the army when I was 17. That's the British Army, by the way, the only one that counts. I spent the next 15 years doing frontline operational service, and then decided to train on something, and it just happened to be IT. The last 9 years were going through the training mill, and I got my last 3 years working with an Army IT unit in defense logistics, just keeping track of stuff, basically. I then almost handed my combats in, donned my civilian uniform before I was dragged back, because I was pretty much the first kid on the block, I suppose, who could make PCs work and do stuff other than just look at them. I then spent up until 2 years ago, I left the Army in 95, up until 2 years ago, working on all kinds of things in defense logistics, from a licensing audit, which was an eye-opener, all kinds of bits and pieces of software and development, and I ended up being what they call independent qualification body on the Voyager program, which is not the spaceship, it's the air tankers. And okay. I rode shotgun on the test program for the software and the transformation on that. That too was an eye-opener for an ex-grunt. And I retired a couple of years ago. And since then, to do with when I read the GDPR, I took one look at it, got to Article 17, and I started smiling to myself, thinking, not a cat in hell's chance, and started to post regularly on it. And I've just literally closed my website down and various other bits and pieces. So this is the last mutterings of a Waldorf, if you like.
It's interesting that the way you said, you're the only one who understood it. It reminds me of the famous quote. There's a David Letterman interview that was, I don't know if it's still on YouTube, and he's interviewing Grace Hopper. And he's like, well, how did you know so much about computers? And I love her response. She's like, I didn't. It was the first one.
Yeah. I hit, let's see, the last part, the first IT posting I got was what they call a small systems group. And that was basically a bunch of people in a small hut somewhere. They didn't quite know what we were doing, but they thought it's best to just leave us to get on with it. And it was the best way to learn IT you could possibly imagine, because it was just to the point where things were moving from mainframe into PCs and desktops, and they were coming from all over the place. Somebody said, release the budget funds to buy PCs, but nobody had a clue what to do with the bloody things. So because at the time I was just coming to the end of my degree level calls, I just got about in a way that simply wasn't possible any other way. And as I say, I left the Army, and I literally walked out, handing in my combats one day, dekitted. And then I got a phone call saying, get yourself back here. We would like you to do yada, yada, yada. It was just circumstance and coincidence. And to be honest, that's the way it's been for me for most of the time since I left school. Yeah, I haven't had a plan. It just sort of things happened.
Speaking of that, I want to touch on one thing you mentioned. They just kind of left you alone. And that seems to be key in a lot of these really pivotal stories in information technology history. And I had the honor of meeting Whitfield Diffie, the guy who's Diffie-Hellman Key Exchange, the father of public key cryptography, at the second DWeb conference. And there was a quote that he said during his interview that has stuck with me. And it's, communication diminishes autonomy.
I think that's about right. What I'll try and do, if I may, is illustrate it with stories. One of the things I did fairly early on was to write a database software with a bunch of my mates to handle small tools, hammers and spanners and all that kind of thing. Because in the military, they scale and equip everything. And they decided that it would be a good idea to actually keep a better track of where all these hammers and spanners are, because, it just makes sense.
Yeah.
Well, I was asked to join up the database concerned with a manpower planning database for my CAP badge at the time. And yeah, okay, no problem. I'll did the work and all the rest of it. But then I ran a report, and the report came out on fan paper, and it was about 40 miles thick. But I decided to check through things just to see what came out. And what came out of it was pretty much a breakdown of the army at the time. This is 30 years ago, nothing like what it is now, of course. I took it to the bloke who asked me, and he was a colonel, and I said, please, sir, don't ask me to do this again. And he gave me the kind of filthy look that colonels do when you say something like that to them. And I showed him the pages, and then he took it and shredded it. It is a matter of part of the, once you understand the nature of connectivity, and that's not necessarily network connectivity, but the relationships between things, all sorts of stuff falls out once you figure out a way to join them up. And it doesn't fall out, in my experience, it may fall out by design, but a lot of the time it falls out as if by accident. One of the guys that I am a great fan of is a chap called Barabási, his surname is, in his book Network Science. And it describes, you've heard of 6 degrees of separation?
Mm-hmm.
But I think I'm right, and in the book he says there's about 19 degrees of separation between just about anything. And I think he's about right. And that generates a whole raft of other problems, of course. But nevertheless, once you have great volumes of data, the ability to infer accurately grows exponentially once you figure out a way to join things up or establish the nature of relationships between things. And that little exercise I described was my first inkling of that. And it's also the time I knew I'd made a good choice in learning about IT.
So I'm interested in... You took an interest in the GDPR, and I'm presuming based upon this interest in how things are linked up and how information is sent back and forth. What was it about the GDPR? What was your first impression of it, and what made you take a special interest in it?
Specifically, as when I got Article 17, which describes the right to erasure. The reason is data has legs. So, and the kind of scenario I choose to demonstrate that is something like this. If you look at the employing a person, then you place an advert for a job, someone will apply, and that starts a conversation. And it's a maturing conversation. So the application form will be filled in, which is another part of the conversation. That will usually be recorded somewhere, as will the initial inquiry. They're both related, but will be in different places inside the architecture, whether it's an email folder or something like that. They then go through an interview process and are finally selected. Well, once they get selected, then they go onto the employee database and so on. Now, let's say, for instance, that the person who's being recruited is going to be a system admin or a coder or anything, geek sort of techie-like. Then basically he or she will go onto a database as with network permissions. So that means in the Active Directory in the Windows world and so on. So very quickly, a single employee can appear in multiple places, and then they get to communicate with other employees using the phone or anything you like. It really doesn't matter. Now, what that means is that if, let's say, the person concerned leaves for whatever reason, and then sends a DSAR, a subject access request. Now, that presents an awful lot of problems technically, because it means in order to answer it properly, you've got to be able to understand that they were in the Active Directory, and to get at it there, get at their employee records, and so on and so forth. And let's say they decide to say, right, I want you to remove it. Now, that represents a considerable data management exercise all by itself. Having seen that and all the rest of it. And then I started to read the rest, and I had a bit of a wry smile, I think is the best way to describe it. Because there's nothing new in the GDPR. But because for me, it's a matter of, and I've had this discussion today as it happens, for me, it's a matter of trying to raise the standard of information management, but in a relatively specific area to do with personal data. But you can't take the person away from the rest. So, for instance, if somebody outside a major customer, say, and the major customer is part of a body that signed a contract, and then that person says, okay, I want to be removed, just the simple process of checking a contract actually means a lot of work, because you can't cancel a contract, say, and it may mean it needs to be revised or what have you. So there's all kinds of things just come out of that one little act and that one little right. And as I say, it is a matter of trying to improve the standard of information management. But I'm afraid one of the things that's coming out all too frequently nowadays is an awful lot of people, and in the nicest possible way, don't get it.
So when you say they don't get it, I presume that you mean that they don't understand that it's not as trivial as saying, hey, I would like to move this bit of information from here to there, or I would like to revise this document, or I would like this particular document to, instead of going here, go over there. It impacts people. It impacts a lot more processes, a lot more parts of the system than they're aware of usually. So, for example, one time I made a proposal within a new company that I had come into, and I was like, well, why don't we just do this? And I had to get sat down and explained, well, there's no such thing as just doing something. They said, first off, we could roll out this little system that you're proposing. And yes, it's a small change, a small technical change. However, it's also going to require that we update documentation. That documentation is going to require training. That training is going to require rollout. There's going to be a lot of processes which, if we add them all up, become significant to our chief financial officer. And we're going to need to actually take your idea, bubble it up to the top, and make sure that anything that you are proposing is a top-down initiative, which gets fully integrated into the whole of the system. And that was an eye-opening moment for me. Now, that was the first time I had realized that you can't just do something within, especially a larger system, a larger company.
Of connected systems and unintended consequences. Really, my apologies, but I need to take a call real quick. I'll be right back. I can't defer this. So I'll just step off screen, and then you guys go ahead and keep going. I'll be right back in 5 minutes.
Well, one of my experiences of just do it. All right, don't worry. One of my experiences of just do it was I was tasked to acquire Microsoft project. And have you ever, I don't know if people have, but there's a television program made by the UK called Yes Minister. It's a tale of government and the way it actually works as opposed to the way it presents itself. It's extremely funny. It's meant to be a comedy, but it's hard-hitting Pulitzer standard journalism as far as I'm concerned. And it took some time to get this in. And part of the problem was this. Aside from the expense, what it did was organizationally, it fell between the cracks of the way the organization functioned. And they couldn't get anyone to agree to sign off on a particular document we needed signing. So I went to my boss at the time, because he was quite rightly getting a little bit frustrated. And I said, right, you come and chair this meeting, and I will take you through with the guys who are sort of providing a block. And you can turn around and use your authority and do whatever it is you like. Anyway, the meeting happened. What I expected to happen did happen, because one wouldn't sign it off. Wouldn't sign off Microsoft project because it was a major program, major application. And the other one wouldn't sign it off because, as far as he was concerned, it wasn't a major application because it was a desktop application. And the meeting went on for an hour. And eventually they got up and left. And my boss looked at me and he said, what happened then? I said, I haven't a clue. You tell me. That's the kind of thing that happens. And the first time I wrote a sensible business case, properly financially planned, took a lot of effort. So, because when you start to cost things, you begin to realize just how much things cost. It was the time that was the time that brought me into the idea of capitation rate. So someone might be being paid 40 grand a year or whatever it is, but the actual cost of the organization is a lot more because of things like pension contributions, taxation, all that kind of niff-naff and trivia, which most people don't think about until you're asked to do it. So you're quite right. It is a matter of, once you start to work out what has to be done, then actually it starts to get very complicated very quickly.
So we have somebody in our chat here. Dutch Guy 94 asks, what kind of reforms could be suggested to make the ability to make changes easier? When my experience with that was to bubble things up to the top and allow it to be. So, for example, if I wanted to make a small change within a larger system, I would bubble that up to the lead decision makers, and then they would figure out how to distribute the idea to the wider organization, and to get buy-in and to have those conversations about, like, for example, if I wanted to suggest, hey, maybe we should use Microsoft Project, then we would want first for the chief operations officer to become aware of this change and to see whether or not they know of others that might be key stakeholders that would be impacted by that kind of a change, and distribute it out. So what I'm wondering is, does that sound naive to you? Is there a better way?
Well,
is there something better?
That's actually a very difficult question to answer, because one of the things I've had to do pretty regularly, you'll have come across the my numbers are not your numbers debate. And that actually turns into quite vicious arguments from time to time. The fact of the matter is that in order to, and sorry, let's take a step back. What I tend to do is use the analogy of making a car or building a car. If you take a car and a car factory and just look at it, it's a multidisciplinary activity. You have drafts. Good.
Sorry about that. Yeah, sorry. I was trying to get Alio back into the shot there, and sorry about that.
No, it's okay. But you look at a car factory, and it isn't just the track that you see and all the rest of it. It's everything else. Now, what that means is when you design a car, it takes a long time to go from the initial drawing or specification of requirement to actually delivery of the car at the end of the production line. Part of the problem with software is there is ephemeral, and people don't understand the nature of the complexity of building a piece of software. And the analogy I use is something like this. Let's say a car, for want of an argument, has 35,000 separately identifiable items. It's many more than that. It doesn't matter. The number will do. If you use jQuery, for example, and call it, it drops 11,000 lines of code into an end-user browser. if you then use any of the other components, then it's not long. And you take the idea of a line of code being equivalent to a part, and this is just to explain it, not in any way. But if you do that, then pretty soon those 10,000, 11,000 lines of code, when you use add-ons, turn into 20,000 lines of code with other bits and pieces and so on, and then there's a rest. And most people don't see that. And one of the things I've tried to do as part of the education piece when I've come across this is to make people sit in front of me or with me on a screen and show them what I actually do, what I actually did. Because I've been told many, many times by people who are senior and project managers that they don't need to know how to run code and how to make code work and still run a software project. That's a nonsense as far as I'm concerned. The people who are increasingly senior need to be trained in it from apprenticeship or what have you right the way through. So coming back to your database migration, the average CRM or ARM contains, there was a document I read sometime, something between 90 and 100,000 entities, data tables. That is not easy. So most people just don't know. What they see is what comes up on a screen. They've got no concept whatsoever of what's going on in the back. And as a consequence, it comes to a point where you have to say, right, you sit down with me and you watch. And then you show them the documentation and all the rest of it. People just don't. When I say people don't know, it's not implying a lack of intelligence or ability or anything like that. It's just they don't understand the nature of the complexity. It's a bit of a cleft stick, because the first major project I worked on, we used a technique called structured systems analysis and design method. And that was, at the time, very thorough in the way it described the nature of the build-up of the specification of requirement. But it took us 18 months to do the documentation and to follow it religiously. It's the only time it's ever happened. But the benefit of that was that the software was meant to have a lifespan of about 5 years, and it actually lasted about 19 because it was built rock solid. Now, again, it is a matter of, I think one of the key problems to it is the ephemeral nature of software. People see it on a screen and just don't know that behind a single button click, there could be tens of thousands and more lines of code. And until such time as more people understand that, and more people who have gone through the junior programmer up to senior management log, because there's also a change in emphasis. So around about once you start getting your own budget and all the rest of it, you have to learn how to handle money, and IT people generally are not very good at that. You have to cross that communication gap one way or another, or somebody has to do it.
I absolutely agree. So I'm a systems designer, and one of the ways that I've found that helps us bridge this gap, certainly imperfectly, but does a little better of a job than just trying to explain a system to especially to non-technical individuals within an organization, is using something called Unified Modeling Language, or UML. And
Yep.
This allows us to create diagrams which show sequences. And you can show, for example, when you click on this button, it's going to call this system. And this system's going to call this system. This system's going to call that system. This system's going to make a database call. And then it's going to return this stuff back up, do a couple of loops, and then it's going to actually display this thing to you. And when you put this in front of non-technical people, even they can be like, well, that looks complicated. And you go, yes, it is. We would love to simplify this process. And so I'm finding that the ephemeral nature of software is a major hurdle in the business world, at least the business world, which is where I work. And the only ways I've found to effectively start bridging this is to bring it into a realm that they can understand, well, that anyone can understand, which is, a visual sort of sandbox with boxes and lines that connect those boxes and provide something that our brains are already evolved, highly evolved, well, highly evolved to be able to relate to, because we have been for tens of thousands of years drawing out our plans for things in the sand with a stick, on paper with ink, and then on a computer with diagrams. And so do you think that this is the best tool we have right now, or do you think that there's something better or maybe this in combination with other things to be able to bridge that gap a little better?
Well, again, if I may, one of the things that seems to happen regularly is the methodology of the month. So something comes along as the next silver bullet. My view of that is there is only what works, and whatever works, work it. But come back to my defense background. There are a number of things that the military do that, in the nicest possible way, I don't think civilians are trained to do. And that is in respect of the way they plan. So you mentioned UML. There is something called DODAF and MODAF, the MOD architecture framework and the defense architecture framework. And that takes the idea, as far as I interpret it, of UML a stage further, because what it does is it shows, the aim of it is to show how things fit to meet an aim or an operational requirement or whatever. And fit means a computer system will physically fit, say, in a vehicle or something, but it must also provide information to enable people to make decisions. So those elements of fit need to be understood too. And there is an acronym which I tend to throw at people called TEPIDOIL, TEPIDOIL. And what that is about is multi-stranded planning. So I'll go through them all. It's training, equipment, doctrine, etc., etc. Now that actually is again sort of stood over by something called network enabled capability, and there is a book called Power to the Edge, published by the DoD, and you can't ignore the DoD because they invented the web, they paid for it and all the rest of it. So if they say something, you sit down, you listen to what they're saying, and you go and figure out how to make it work. So this book, Power to the Edge, was recommended to me by an American aircraft engineer, very clever bloke. And I can't recommend it too highly enough, because what it does is it makes you think along the lines of multiple strands of activity to achieve an aim or a goal, with the aim of providing the correct kind of information in context to the people who've got to make the decisions. Having said that casually, it took me years to figure out how to actually say what I've just said. It is a matter of the way I was taught IT was strongly linear and strongly procedural, because that was the IT I learned on, and it just isn't anymore. My view is it now that just about every interaction between a bunch of people and a network is conversational. It is organic and it is viral, and it means that there has to be a change in the way that people think about just what a system is. And as I say, that my view is through life, and there is a thing called the CAPMIT cycle concept, which if somebody has a good idea. Assessment is the idea of viable. Demonstration, okay, let's mock it up. Manufacture, make it. It'll be run in service and then eventually be terminated, or rather closed down. And what that does, within that, and each one of those will have a TEPIDOIL multi-strand set of activities behind them, and so on and so forth. And each of them will have their own methodologies and professional standards of working and all the rest of it. But you've got to be able to have that kind of mental model to be able to figure out yourself how to join it all up. And again, it's a matter of a prince is a quite famous project method management thing. Prince has specific stages and all that kind of thing, and it has specific roles and so on and so forth. But it is about the linear management of a project rather than how project will fit into the wider operational environment. And I think one of the gaps is that people fall into time and again, and that includes me because I've done it. You go and write something, you put it in front of a user, and it doesn't work because they don't know. They do things, and you with the best will in the world, you look at the screen and you go, "How the hell?"
There's the famous joke: you can make it idiot-proof, but they'll just invent a better idiot.
That's right. There's a bloke called George MacDonald Fraser who wrote some books about a soldier called Private McCausland. Anyone who served in any army anywhere will know what a Private McCausland is. He's a walking disaster area, and you can't let him do anything with it. So there's them all over the place, and there's us geeks sitting down and being all logical and all the rest of it. We put in something in front of someone, and bingo.
So something I'm really curious about, you're mentioning the difference in, different ways of planning. And we talked a little bit about cybernetics and also quite a bit more prior to the show. I don't want to necessarily call it a dichotomy, but the way that the military, like the internet, was designed by the military for military needs. And then it's kind of been taken over by business and has now morphed into something that much more fits business needs with this return to centralization. And the way you're talking about UML and going beyond UML and really planning something out, when I look at like high assurance systems in the military and software that's built using formal methods, and I was told, I had the privilege of meeting some guys who had spent decades. One guy had, he had worked on all these cleared projects. He's like, look, I can't tell you maybe 1% of what I worked on. I can legally tell you. You're going to have to figure out the rest on your own. But they gave me good pointers. And one thing they said is, look, there's more than just great. You're building the program in Haskell or Coke or Idris or something that allows you to fully verify the code. And even assuming that goes perfectly and the code is perfect, they're like, there's these other 11 areas that you have to get right in terms of interfacing with people and documentation and all this. So there are these very different approaches. And what I've been trying to sort out in my own mind, and one initiative we're working on to try to get companies to move to using better methodologies to build software and systems and make fewer mistakes and have fewer security issues. What do you think, pros and cons, just general thoughts, and what's the balance on where should we ideally be when we look at an incident like SolarWinds? What is the fix, and what is is there a place for moving toward more rigorous design? Where was the major failing, or what were the several failings? Like, I don't know. How do these concepts fit together in your mind, or do they not?
Right. SolarWinds, I think, should never, ever have happened. And it is a demonstration of systemic failure across the piece, not just for the company concerned, but right down to the customers and so on. It comes to issues of trust and et cetera, et cetera, et cetera. So, for me, the key element of SolarWinds was something like this. There was, if you go and check on the Microsoft website, they've got SolariGate blog and all the rest of it, which is a document I think everyone should read. And I actually think this stage should be a case study of what can go wrong, going wrong all at once. The primary technique was to get some code inside of the product architecture and then get it digitally signed. Now, then there was all of the rest, and the most. There was so much cleverness about this; it's just not real. But the next step was to make it loiter, and then announce itself after 2 weeks to make sure it wasn't detected, and so on and so forth. Now, it seems to me that, and I'll probably get hung for this, but there is. The Agile Manifesto, if you look at it, it makes sense in as much as it says, let's try and cut the admin nonsense down and we'll get the developers to build things faster, quicker, and all the rest of it. But to my mind, that means three things. First of all, highly competent developers. Secondly, highly competent developers that know the architecture of the products that they already have. And third off, highly competent developers that know the nature of the business they're supporting.
Mm.
You can't have just anyone going in and producing code, or rather you can, because people do. You shouldn't have people going in and doing things quickly because that's what it says. Now, it seems to me that my background entirely has been a matter of security, a matter of making sure things work, because for all kinds of reasons other than just professional pride, because people were making major decisions on it. So everything I did had to be documented. I mean, I sent you a copy of the DPIA.
Yeah, thank you, by the way.
That's the kind of thing, the standard of documentation that I was used to providing, minus the spelling mistakes. It is a matter of, if you have huge amounts of code, it makes absolutely no sense whatsoever to just have it sit there doing whatever it does. And then when it goes wrong, the guy who's wrote it originally has disappeared or what have you. So it must be documented, because otherwise you end up having to rebuild things. Yeah.
Well, that's the whole idea of literate programming, which I'm curious your thoughts on, writing the docs first and then augmenting the augmenting the docs with code, which you see now with like Jupyter and Python, and there's notebooks that you can write the whole notebook. Like you can write a scientific study and embed executable code that'll run and prove the examples in the study, which I don't know though. There's pros and cons to that. So in theory, the solution to what you just proposed is literate programming, but in reality, it hasn't caught.
In the business world, the terms that are catching on are living documentation. So the idea that this documentation, if we're describing an API, would have actual code embedded, little widgets embedded in the documentation where you can shoot off a request to the API and get back a response, and you can tweak the parameters and see what happens right there in the documentation. And also the term documentation-driven design is also starting to catch on.
Well, again, if you, I'm a fan of Microsoft, for instance. I should say, I think they've done remarkable things over the years. But if you go and look at their technical library, their TechNet, that's exactly what they've got. Everything is well documented. I had occasion to look at the documentation for the Active Directory a few days ago, and it is a matter of study and effort to understand what the Active Directory does. But if you don't know what the Active Directory does, then actually something like SolarWinds becomes an even greater risk because of the nature of the security risk attached to it.
Yeah.
Now, Microsoft, to their credit, and IBM through Jazz.net and Oracle and what have you, have documented their stuff to the nth degree if you know how to look. And that's part of the problem too. How do you find things? But as a consequence, if they are executing that kind of best practice, then it makes sense for people to do the same thing themselves. If you are running a website that turns over a couple of £1 million a year in business, then it makes sense to make sure that the website can be recovered, or in the event that it fails or what have you. And you can't do that. All you've got is just a bunch of code.
Yeah.
Or it just takes longer.
And so I have two additions, I think. The 3 points you mentioned about having competent developers that also understand the problem, understand the tool chain, and understand the actual problem. In addition to that, how do you keep the documentation synced so it actually, what the documentation says matches what the code does? And that's not just a problem in docs, that's a problem if you look at formal methods and model provers, one of the advantages of like Ada Spark is that the code and the model and all this are the same. But if you model a system in like TLA plus, cool, great, like the model should work, but then how do you make sure the TLA plus code is not the actual code that runs in production? So you have this gap, and you have to like steal an idea from circuit engineering, electrical engineering, called LVS, layout versus schematic. Because when you take a logical schematic that says how everything connects, and then you try to transfer that into a two-dimensional mask on silicon, things better connect the same way, because like a layout, like logically what connects has to match physically the limitations of connecting everything in 2D. And then the final thing I'd add is that even with the best developers out there, I think you have to have tooling that makes bugs really hard to make, because every study I've seen, right? I think you know where I'm going. Every study I've seen, and they're out there, but you got to look. They're, unfortunately, you'd think that everyone, right, would be really interested in how do we make less bugs? How do we make more solid software? And there have been a lot of studies, but no, not everyone's talking about whatever trendy technologies out there, not how do we make better software. That's not a popular discussion. And there is a lower limit. So the best I've seen, the best I think in any of these studies is like 5 errors per 1,000 lines of code, 5 external errors that despite your best efforts, despite how many decades of experience and how diligent you are, there's going to be at least 5 for the best, most elite, most incredible. They have plenty of time. No one's breathing down their neck to ship. 5 per 1,000 lines. And it's usually a multiple, like it's usually 5, 10, 20 times that high. So even with really hyper competent and vigilant developers, I think you need to bring in an element of formal analysis or contract-based design or any number of these technologies to help fill the gap and catch those errors that are going, even in the best developers, are going to make it into production anyway. If everything else, all the stars are aligned every other way.
Yeah,
Sure.
of course. It's a case of there is something called through life management.
Okay.
And one of the major problems that I was asked to address once was putting together a document library that reflected the concept of through life management. It took some time to get just the folder structure right. I'll pass you a copy to have a look at for what have you, and how
much appreciated.
Explained. But basically, the idea of through life management is that you have, I think it's 20 odd separate sections and then subsections below that. It looks quite complicated, but when you can get a set of paths, folder structure paths that are correct, you can automate a lot of it. You drop a document in there, and then you can do all the rest. But that simple act of organizing the way documents are placed goes a long way to solving a lot of the problems to do with what did they do this for, what did they do that for. So it's not just a matter, again, of writing code. It is a matter of controlling the documents associated and applying the same kind of principles that librarians apply. And one of the things I've said quite a few times now with to do with the GDPR is that because GDPR is also about document management. It's not just about databases, because people sign things. Is that if you really want to know how to manage documents, go and find somebody who works for a major government department at a senior level and ask them how they do their work, because they are expert at it. You go and get a document from someone like that. If you don't bring it back in the same place, all the pages ironed and all the rest of it, you'll get nailed to the floor. It is a matter of, these things are not, they're not written for devilment. They're written because they are artifacts of the system, whatever it is, and they need to be controlled. And they need to be controlled in sync with everything else. Now, it is a black art. There's a whole different language to it and so on and so forth. But that's another thing that has to be learned. And it's a case of, if you look at many of the major hacks, you can just see the amount of time it takes to address the issue and what have you. In fact, no, the TSB, Trustees Savings Bank in the UK, they did a major upgrade of one of their systems. There's a long, convoluted financial stories, whatever, but it all went to rats. And the chief executive officer was heard to lament, well, the reason it went to rats is because nobody knows what the geeks are doing, or words to that effect. And what, again, it is a matter of, you can't, it's part of the management of technical people to make sure that they document things and that the documents are secured in their own right. And that too seems to have been forgotten. So like I say, what I'll do is I'll send you the through life management plan structure and some notes associated with it. You distribute them wherever you like.
Okay.
And the purpose of sending it is that it's a pathfinder, not gospel. It is a matter of, this is the way I did it. Have a look. It's about right, but there is things that will need to be tailored. But as far as I'm concerned, if you have something as complicated as a major piece of software and you do not document it, then all that's going to happen is at some point it will come and bite you, because you'll be employing people who don't know what it does.
Yeah, that's I'm thinking while you're saying this definitely aligns. I can't wait to see that document, and I probably will share it around, because I'm on a number of committees and coalitions. I advise some schools, and so the trend over the last 5 years has been people are finally starting to say, okay, just knowing the code, knowing how to code, knowing all these fancy developer tricks is great, and that's good. And we want someone who's competent and understands the tooling, but we want soft skills. We want people who can talk to other people, and that's become the number 2. And in a kind of distant number 3 category, people are finally starting within the last maybe year or two to say, communication and the ability for these developers to talk to other people, to talk to management, to talk to the customer, to document, as you're saying, like we're starting, there is a ray of hope. We're starting to think about that and actually look for that.
Well, there's an imperative. Again, coming back to the GDPR and probably the CCPA, but I don't know that quite well.
Okay.
Inside the articles of the GDPR, and incidentally on that, people should also read the national level legislation as well, because that's an absolute scream. Inside the GDPR, as far as I'm concerned, what it's about is bringing back quality assurance and the monitoring of quality assurance to the DPO into general IT. It asks for a record of processing activity, for instance. Now, if you actually start to write a record of processing activity, then part of the problem is what counts as processing. So if you take a single web page and you look at it, then there is the pre-header block, which can operate server-side. There is the header block, which contains all kinds of stuff. Then there's the body, and then there's the footer and all that. In other words, there's a model to it.
Yeah.
And each of them can be made to do different things independently of the rest. So that makes a simple web page rather complicated structurally, let alone the rest. And it isn't something that you, if you make a change to a web page, then actually you're doing more often than not some sophisticated information management. So the ROPA requires, just about every web page will require a record of processing activity to describe what the nature of the page does. Now, the follow-on deliverables, and there's quite a few. One of them is the DPIA. So if you have 8 lines of HTML that do what I describe in the one I sent you, then actually it makes sense to describe what those 8 lines are actually doing. Not necessarily because to understand the geekery, but because if things go belly up and the authorities come to call, what you've got to be able to do is prove that you have been carrying out the right level of due diligence to deal with or to minimize the risk associated with the problem. Now, that then leads on to how do you do risk analysis, running things like a data dictionary and all the rest. So it is, to me, about bringing back the idea of quality assurance throughout the whole system lifecycle.
Yeah.
And at the moment, part of the difficulty is that people don't know how to do this stuff.
Yeah, and there's another aspect there. You talk about all these documents, and I think an underappreciated issue in security is correlational attacks. And LaTanya Sweeney has done some amazing research. And what the Snowden leaks showed us is it's actually less interesting to listen in to the text of someone's calls. It's much more interesting to just look at the network of who are they talking to. So even if you're not keeping all of the web page content in these documents and you're just making a record of this person asked for this page and then this page, that's almost much more useful, more interesting, and more sensitive than what was actually on the pages in many cases.
Yes, I'd agree with that entirely. I mean, it is a matter of what you have is, it is not procedural linear. You have a sophisticated organic and viral interaction, and you don't know what the sensitivity is until somebody comes along and asks the question. So, but you can't even start if you haven't got what the pages do written down.
It seems to me that, we're jumping from one nut to another bolt to another, from component to component, when we're talking about documentation, talking about the engineers themselves, talking about the code, talking about the practices with that code, the project management, the executive teams. And this is where the field of cybernetics really lends itself to usefulness, I think, because we can take all of this and we can look at it through the lens of cybernetics and try to look at, for example, any one of these organizations, for example, SolarWinds, and look at that as a cybernetic organism. And when we say cybernetic organism, we're really just talking about, it's a collection of both technology and people, and they're working together. In some industries, it's technology, people, and animals, and it can be, but the idea is that there's hardware, software, and wetware. And the wetware being people.
If I think you're dead right. Are you aware of the British Airways hack?
No.
Right. You've heard the word mage cart?
Not myself, okay. No.
Mage cart is another kind of insertion attack, typically through JavaScript and what have you. It hinges on getting a point of entry. Now, the British Airways were hacked, I think it's almost 18 months ago now, more or less. The final report was issued by the UK ICO. They were fined an amount of money, and the original fine was much higher, and then COVID came in, and all this is all to do with the nature of due process and what have you. But what they've had to do is set aside a considerable sum of money for compensation, because what the hack did was essentially the nature of the major risk was that they managed to get hold of the customer details of N number of British Airways passengers. And the fine might have been a few million quid, but it has nothing to the compensation claims that come. Now, again, if you like, I'll send you this document. You'll have to nag me for this, just make a note or something, but I'll send you the UK ICO summary of what actually happened. And for me, it goes something like this. There's a phrase going along about the nature of the supply chain. By that, it means things like data lineage and code lineage and all the rest. And increasingly what happens is, in many industries, a closer sort of idea of automating the nature of cooperation between one company and its processes and another, and you build gateways through Cisco or something, it doesn't matter.
Yeah.
Well, what these guys apparently did to get into the British Airways thing was went to one of another organization in another country that was connected to British Airways, got their code, got the break-in, then got through the Cisco and all the rest of it. It's very sophisticated what they did, but then they got into the passenger list and the credit cards and all the rest of it. Now, again, it becomes a matter of the idea of a system being just a bit of software is increasingly a bit of a nonsense. And the same applies with SolarWinds. So if you look at SolarWinds, the reason that I am in awe of that thing, because what somebody must have clearly done was identify a particular component and then realize they had a chance of getting this particular component into a shed load of very sensitive organizations. That they succeeded probably blew them away. But all of that comes down to the idea that you had SolarWinds operating as an independent entity, making the code, offering it up as a download, and then being inherently trusted because they were SolarWinds or something. I don't know, but it'll come out in due course.
Yeah.
But what that means is that the people running the SolarWinds software were heavily dependent on something over which, organizationally speaking, they had no real control. And I mean that in terms of management and financial reporting and all that stuff. Now, again, that turns round to the idea of the way you look at the nature of a system, to my mind anyway. And one of the things that I found happening, and it comes back to a cybernetic way of looking at things, is your DoD is introducing something called CMMC. On the last post I put on LinkedIn, there's a link to the document. Now, what that is about is capability maturity. And capability maturity, if you research that, came from Carnegie Mellon. 5 stages from total chaos to superlatively wonderland that nobody lives in, up at number 5. Now, out of that comes something like this. On one of the sites to do with CMMC I looked at, it said that in the not too distant future, getting a government contract without being CMMC level compliant is just not going to be possible. And again, that's something I'm used to. But what that means then is this. Somebody somewhere has taken a decision that the idea of the system in sensitive areas doesn't just mean the building that whatever bit of tool is being used, it means everything else. And what they seem to have clicked onto the idea is that, okay, well, if that's the case, we'd better go and check. And we'll check and we'll review. We'll get our guys to go and do it at some point, and we'll check and review to make sure everything's meeting our standard requirements. Now, again, that is something that I was used to working in for many, many years. So getting a piece of software inside of the UK defence intranet was a very expensive and very time-consuming business. And what it went through was rigorous integration testing, because one of the things you could not do with anything was cause any risk at all to what was already in place, if that makes sense.
Yeah.
Now, again, it's a matter of that kind of attitude to life has to be more universal than it is, because as I see it, the nature of the failures of an architectural nature are at an unsustainable level of financial hit. Yeah, I would agree. If the cost of breaches is currently estimated to be around about $1 trillion.
Yeah, annually, by the way.
Yeah, it's that makes absolutely no sense that you just let things carry on as they are.
And so that's the cost of breaches. And then there was another article that, quite to my delight, came out. There was a study from SysQ about software quality. And they said in 2020, the cost of, well, and this is, I would say, I'm going to guess this is an underestimate. I haven't reviewed the methodology of the study. But for bugs and downtime and all these other non-malicious things, the cost was $2 trillion for 2020. Yeah. So that's $3 trillion right there because of bugs and issues.
So doesn't this then? Sorry, go ahead, Al.
No, the way I think about it is like this. When I first started off in IT, there were a bunch of people in a computer room, and nobody went in the computer room except the people that knew what the computer room did. Now it's commoditized.
Yeah.
It's the same kind of infrastructure as plumbing or electricity and all the rest supply. I looked up how many Apple phones there were, or Apple devices there are. They're in the billions now.
Oh, yeah.
The nature of connectivity has, as a consequence, got more and more complicated to get a grip of.
Yeah.
And there has to be a realization that that is the case. And there has to be the great and the good, the adults have to start thinking about this.
Yeah, well, that's something I want to highlight from what you're saying is, yeah, it is kind of like plumbing and electrical where it does connect, but there's a deeper meshing, like the stuff you talk about in the British Airways attack.
Yeah.
Just like the Target hack. They went in through the HVAC vendor and they snuck in because the systems were too well connected. And people have kind of lost sight of this issue of cascading failure, which also cascading failure just within the power grid was, we had the East Coast power outage in 2003 was because of connections in the grid. And it took out 5 states worth of power grid for quite a while. Yes. And so what we're doing is we're connecting all these things. And when you're talking about assessing risk and saying, how big a problem is this? We get to going back to what you said in the beginning, this, 19 degrees of separation for anything. The more and more we connect, the more readily we provide routes to allow failures to propagate. And the faster things can react and get directly connected, the faster it propagates. And that's something that I've said before is you look at like the banks versus cryptocurrencies. And if everyone makes a run on a bank, well, there's a limit. They're only open so many hours a day. There's only so many teller windows. It takes so many minutes to conduct a transaction, pull all your money out. So if something happens and people freak out and make a run on the bank, it's going to take a few days, if not a week or two, for everyone to empty the bank. And in the meantime, that thing can resolve and it's like, oh, it's not the end of the world. Like, never mind. Your money's safe in the bank. It's fine. And so only a small portion is, pulled their money out and they can just go put it back in, or just, it's not that big a deal. Versus the Ethereum flash crash, where the entire market dropped to basically zero in under a minute, faster than any human could intervene and respond. And then it bounced back up because everything's all hyper connected and there's no friction. And so what I think we've ignored is there's a damping effect that having lag and latency and some friction and not connecting everything and not making it all instantaneous, like, we're building this system where one little error could potentially propagate out and just into society instantly. And we need to slow down and add some damping. Yeah.
That pretty much sums up SolarWinds. Basically, it is one relatively small file that somebody played around with that had a profound effect across US government. And there's no other way to describe it. Have you heard the name Shoshana Zuboff?
No.
Right. There is a book called Surveillance Capitalism.
Oh, I've heard of the book. I haven't read it yet. I'm still tracking that one down.
You should.
Okay.
One of the things she did was she teaches in one of the famous, I think it's Harvard she teaches in or something.
Okay.
But she, in her book, she mentions something about a thermostat, an industrial thermostat inside a factory somewhere. And what she did was she got a few PhD students to examine the thermostat and to see where the data went that it was generating. Now, it was a simple thing, just recording temperatures nominally, ha. But they stopped at 1,000 connections, just for that one little device sending stuff out into the web. And the nature of the connections that are just there, and it's been an eye-opener for me, I have to say, because I've started examining websites to see where they go and what's going off as best I can. But the nature of the connectivity now is you can't keep track of it. You just can't.
Yeah.
When I closed my website down for the following 2 months or so, I was phoned by people. What are you closing your website for? And all those. And I'd explain. And they'd say, I'd send them the DPI I sent you. But what I'd also do is offer to show them using their websites just what the nature of the connectivity was. Those that actually looked just on include statements and a few other bits and pieces, the general reaction was, wow, followed by, we had no idea. Because what it also ties into is the nature of the legal requirements is to do with terms and conditions and so on. And each of these things where they connect to generally has terms and conditions which are there to limit the liability of the developer, whoever it is or may be. It's all perfectly normal and all the rest of it until you point it out to people what some of these things actually say. So as a consequence, if there are components that I would no more use than I would, I could be rude and what have you, but I won't be, but I just wouldn't use them. Not because there's anything technically wrong with the code, but because of the rest that's attached to it to limit the liability and responsibility of the developer.
So I'm interested in your opinion on the idea that organizations ought to carve out a space for, say, a chief cybernetics officer, for example, somebody that can look at the organization from a holistic point of view, look at all of the components that are being proposed by all the other folks who are going to be specialized. So somebody who's in charge of product is going to be really singularly focused on designing a great product that customers like. Engineers are going to be singularly focused on fulfilling acceptance criteria and making sure that the thing that product asks them to build is built according to specification. Architects are going to be singularly focused on the architecture of making sure that this thing is scalable and it can work. But don't we need somebody else that is going to look at all of them as sort of a watchdog and say, yeah, well, the left hand doesn't know that the right hand they're both working together to create a vulnerable spot in our company that can be attacked or that could be exploited. Doesn't it seem like there's at least to me, it seems like there is a need for somebody that is, and we could say, well, this should be the executive, the current executives, but they're also singularly focused on other things. The CFO is going to be focused on the financials. The executives, the CEO is going to be focused on external relations and finding new market opportunities. The COO is going to be focused on making sure that the actual operations of the product and the engineering and the architecture teams, they're all working together. But what about somebody who's going to look at the whole of the entire organization, the people, the processes the people follow, the every possible way that the world can interact and what kind of interfaces this organization has to the outside world, what kind of interfaces are ingoing and outgoing do we have, and essentially have the singular focus of looking for ways that that all of these folks might innocently be creating vulnerable spots, not just within the company, but vulnerability to the rest of the world. Maybe we're creating a situation or we're creating a capability that is going to be threatening to the rest of the world, and we now know that eventually the world catches on to that and punishes corporations that do that eventually. So I'm wondering, what do you think about this idea of the chief cybernetics officer, somebody who really does look at the whole of the organization as a cybernetic organism, really does look for ways to be able to prevent these things on a holistic level?
That kind of person, that kind of employment, as far as I'm concerned, already exists in the enterprise architect. What another of the sort of many hang head moments is that why on earth the idea of enterprise architecture hasn't got into the likes of privacy and the GDPR, because what you're describing is, as far as I'm concerned, what GDPR compliance is about. It is a matter of, there is a discipline or a professional calling known as enterprise architect, and she does the kind of thing you are referring to. In other words, sits astride the disciplines of business, compliance, and all the rest of the things. It's a very difficult thing to do, but nevertheless, that calling is already there. I'm at a loss as to why, when there is so much stuff on this subject area, that more and more people aren't actually taking on board in the way you've described, because there is a clear need.
I find it terrifying that I've just learned of the term enterprise architect just now, like that.
Yeah, you're not exactly junior level. It's been about 2 decades you've been in the field.
Yeah, I've been working in the tech field for over 20 years, and I've never heard of an enterprise architect, because they've never, if they have existed in the companies that I've worked for, they sure have never come around and asked us any questions.
Okay, I'll give you a book. Cast it into your heart. The Bible. Living Systems by James Greer Miller. It is worth it for the concept of fray out alone. It is a masterwork. As far as I'm concerned, I was pointed at it by a guy, a senior IBMer who worked with New Zachman and all the rest of it. It is absolutely brilliant. I just looked at I got to the preface and started reading it, and I thought, well, this is the Bible. This is one of them. There is another one by another of my contacts called the Privacy Engineer's Handbook. Again, I'll send you the bits and pieces and all the rest to describe them. That too takes an enterprise architectural view of the way things should be joined together, and so on and so forth. It comes back to the idea of the organization as a system rather than the system as a bit of software. And unless and until you can get your heads around that, and it is, I mean, when I came across, let's see, I have to smile when I say this because it's going to sound totally and absolutely weird. There's a Chilean guy called, not long deceased, called Humberto Maturana. He was a biologist. He wrote a couple of papers on frogs and their eyes. And the idea is that the reason a frog, and I'm being simplistic, but the reason a frog is the way it is because of what it sees. Okay? Now, that sounds bizarre, except that when it was published, the guy who published it, Humberto, didn't think it would go very far, but it was one of the most popular scientific papers downloaded of its time. He wrote three essays in a book on cognition and something called autopoiesis. Again, it is the matter of the nature of observation and so on. And when for me, it was a light bulb moment. You can only see what you can see. And what you can see is influenced by your own personal biases and so on. And that's always going to be there, but you need to understand that that's there.
Yeah.
So when you get somebody, let's see, in my way, let's say you take an infantry rifle, and the concept of ownership, which is another thing, is misunderstood.
Yeah.
You get an infantry rifle and it's made by somebody, and it consists of a couple of hundred parts and all the rest of it, and it has cleaning materials and its own infrastructure. So they see the rifle one way. The guys they then hand it over to the military or what have you, and it gets stuck into an armory in bulk. And that brings a different way of looking at ownership, because although they're registered numbers and all the rest of it, they have crates of the things. Mm-hmm. Then it will get issued, and it'll get issued to a unit or something like that, and then it'll be given and issued to a rifleman, and it will be his. So you have three different concepts of ownership. So the maker owns the manufacturer and all the rest of it. The person storing it in the base warehouse owns the bulk of the rifles, but the rifleman owns it, and they all see it slightly differently.
Yeah.
It's still a rifle. And the same concept applies to so many things. So as a consequence, and you also have ammunition and all the rest of the stuff. So as a consequence, you cannot take even something as simple as a rifle and say, in any one stage, the concept of ownership is static right the way through. And that goes across the piece.
Yeah. And I'm sorry. I just can't help but thinking your anecdote about the frog. What does that say about the scallop? Because it turns out they have shockingly good vision.
Well, yeah. But when I sort of, the reason I'm reluctant, I get sort of, when I explain about frogs and eyesight and all, one of the things about cybernetics is that it's full of mad sounding professors usually with German names that look like something out of a Frankenstein movie. The fact of the matter is that it needs a change in mindset and a change in the way of looking at the way things work together. And like I say, in my day when I started learning about IT, I was taught in a strongly linear and procedural way because that's the way computers work. It's just not that way anymore. If you have, so in my house for the minute, my wife has networked the entire place. The day the fridge won't give me an ice cream is the day I find out where my axe is and the fridge gets a kick. It is a matter of the nature of connectivity, and I keep on hanging on to this. The nature of connectivity has changed out of all proportion, certainly over the last 5 years. And I think seriously there has been a loss of control and an inability to understand the management of the complexity of connectivity. I just, I can't. There are people who get it. Jeff Bezos is a hero of mine because I think he's a bloody genius. You look at what he's done and how he's done it, but you also have to take into account it's taken him 20 years to get to the where he is. He's on a different planet to the world.
Most. Having worked at Amazon at one of the major teams, having seen how the sausage is made, I'm not going to disagree that in some ways he's visionary, but I will say, like everyone else, like the frog anecdote, there are limits. Like he has some blind spots, or he just doesn't care about certain things.
I know that comes down to a lack of control. Eventually, no one person can control everything.
Yeah.
But nevertheless, the concept of the way it was described was, one of his quotes, and I'm going to paraphrase rather than do it precisely, was, I'm not particular. If somebody buys a shirt, I'm not particularly interested in that one person buying a shirt. But if 100 people buy the same shirt, then I might get interested if I've got 100,000 other people of the same social economic group who I can sell the shirt to.
Yeah.
And that's what he's done.
Yeah.
Now, behind that simple statement, there's a shed load of effort and work and things going wrong, no doubt, because that's the way it is. But nevertheless, that's the kind of thinking, at least at the principle at least at the level of operating principle, that needs to be more common than what it is. And at the moment, it just isn't.
So is it fair to say, like the frog analogy, I think it's very interesting, and it sounds less strange to me than I think you thought it would sound, which is, or
we're all just weird, one of the two.
Yeah, that's good.
But the way that the frog's looking at the world sort of gives it the cues for what it needs to get better at, what it needs to improve on. And over the course of millions of years, these eyes have given it the feedback that, that it needs to, maybe jump in this certain way and go for this particular fly and things like that. And this plays into, natural selection as well. So it's, certain frogs decide, well, hey, my eyes tell me I should, that this flies over here. I'm going to jump in this direction. And by jumping in that particular way, it makes them more visible to birds and they get eaten. And now what you're left over with are the other frogs, right? So to me, it makes a lot of sense that it's the way that we perceive things from our point of view will give us the cues that tell us how we should be improving our own operation of whatever it is that we're doing. But it is very personal to our specific way of looking at things. Whereas there are other points of view, there are other, like with the ownership argument with the gun, we have many different ways of looking at this gun. And it also would dictate, for example, the person who's running the warehouse might think, well, the way we could improve these guns is by making them smaller. So we could pack more of them into these crates. Maybe, and then the rifleman, the infantryman might say, well, the way we could improve this is by actually making it longer. So this way it's a little more accurate when I'm using it. And there's actually they're at odds with each other, because the person who wants to store them doesn't want them to be longer, and the person who wants to shoot them does want them to be longer. And then the person who's manufacturing them is just like, I don't want to make any changes to them at all, because I don't want to have to incur more, production cost. And so I find it very interesting, that analogy, and I do want to learn more about that concept, that what we see sort of gives us, that basically multiple people can relatively understand the same thing differently, and this can lead us to some dissonance within an organization.
And that's why you have someone like an enterprise architect,
right?
Because the trick is to strike a balance, and the balance is based on affordability, and imperative to succeed, as far as I see it. But there is one job I would not want to be for all the tea in China, and that's a GDPR DPO. Certainly not one delivering the service as a service.
And that's to expand the acronym, Data Protection Officer.
Yeah, I would not want to do that job for all the tea in China, and I would, of the least ways, if I was a DPO, I'd be the DPO from hell. It would be a case of an enterprise architect's job is a minefield, but somebody has to strike that balance. Now, typically it would be the CEO, but the CEO would do it on the basis of whatever his decision-making process is. But the idea of an enterprise architecture is somebody in a position to present the evidence objectively and to strike a balance based on evidence that can be retrieved. At the moment, that kind of thing just isn't there.
So I have a question, because we only have a few minutes left, but I have a question that I want to tie in to some of the analogy with the frog and some of the other stuff we're talking about. Metrics, yeah, I mean, not quite as humorous as the scallop example, but yeah, seriously, go look up scallop eyes. They're amazing. They're like refractory telescopes. So metrics fixation is something I've been studying. And in my mind, metrics fixation, or my favorite term in a video game article, is metrics fetishism, where people find one metric, and then whether the metric is profits, whether the metric is grades in school, whether the metric, whatever it is, people just fixate, and that one metrics that supersedes every other thing. And you get Goodhart's law and the Cobra effect and all this, where the whole system starts to warp to accommodate that one metric. And I see that as the root of a lot of dysfunction in our schools and our business, and every facet of life, especially in America, is being distorted by which metrics we're choosing or falling into. And I'm curious how that fits into what you're talking about and your thoughts on that.
Ever read the book called The Puritan Gift?
No, haven't.
Then please buy it.
Okay.
It's by two guys who were senior execs in Lehman Brothers just before the crash. It is described in some quarters as a history of US management.
Interesting.
For one, because for no other reason than there's nothing else about. One of the things that initially influenced me was the idea of something called the balanced scorecard. From Kernighan and Ritchie. It took them 3 books to get to the idea of what's called a strategy map. And what it's the reason for the strategy map is the nature of metrics and measurement and all the rest of it. The Puritan Gift is not at all kind to the likes of Deming and so on, for much of the kind of reasons you describe. The way I see it, and again, I'll send you some graphics that explain it from my perspective. Performance reporting, which is something IT should be good at, is multidimensional and multi-perspective. So the balanced scorecard has a number of quadrants as perspectives, which are in effect gateways into a view of the information. So I use the 4 E's: economic, efficient, effective, and evolve. But what you should be able to do is say, let's say you have a training budget of 20 million quid. Part of that is to get 20 chartered or senior engineers in. Well, as part of the evolutionary quadrant, the recruiting process of those 20 engineers should show up somewhere as you recruit them. And as you recruit them and deploy them and use them, you should be able to see improvements in internal effectiveness and external efficiency. So you should be able to establish a relationship between them, but that is multidimensional in as much as there are financial aspects through the TEPIDOIL log. There is also then a series of transitions, as far as I'm concerned, to do with the nature of transiting from data collection to the use of predictive analytics and so on, where data will go through several stages. So from the raw through to things like fact tables, alignment across multiple processes and so on and so forth. All of those things have to happen. So, and what that does then, it gives you the means to understand what's going on with the admiral and the sailor. Unless you understand the nature of the relationships between things and how to exploit them, then actually you're going to be forever tied up in this business of my numbers are not your numbers. And again, it is Conceptual Geometry is a video. It's by a Swedish mathematician. I think it's a brilliant bit of work, because what it does is takes the idea of a taxonomy.
Okay.
And where is, as far as I'm concerned, the general mathematics to do with pi, circles, and parallelism and all the rest can be fixed and defined. The nature of relationships between things can't be defined in the same way, but they're still there. So you end up, if you take a graph, for instance, you have nodes and the connectors between the nodes, then actually the diagrams seem to indicate that they are one-dimensional, but they're not. And that's the kind of thing I'm trying to get at, pardon me, with the idea of perspectives, dimensions, and what have you. It's all constrained by time, in as much as the relationships between things are transitory or maybe transitory, but they may also be permanent. And all of that kind of thing has to be understood. But you can't do it unless you have some kind of mental model as a matter of architecture to be able to handle it. And as I say, I'll send you the stuff that I came up with. One of the things that is always missing is a means to describe organization, form, function, and purpose in a form that is, if you like, generates metadata that can be tapped into and plugged into the rest. And there's a guy called Nicholas Figuet who is doing some, as far as I'm concerned, remarkable stuff with that, and Archimate from the TOGAF group.
Okay.
I wrote some software many years ago which can do that. I just didn't have the words to describe it. And I used it up until I nearly finished. And I'll send you stuff to describe the nature of that software. But basically, once you can start to map, fill in the meta gaps, then actually it becomes easier to tap into that kind of data and information that's all out there.
So, Alan, I'm impressed by your ability to cite, authors, books, and different things. I come from a background of reading what I can get online, and every once in a while I will see enough people recommend a book that I'll pick it up and I'll actually read it. But one of the takeaways I'm getting from this conversation is that I need to read more books. And I'm going to go through, and in the show notes, I'm going to put in notes for each of the books that you've cited so far. But are there some top books that you would recommend for being able to understand more of this problem, more of the solution, and how to get to a place where the world is building stronger systems that have less damage on the world, less damage on the folks who are working within the systems. Do you have?
I'll send you a reading list.
You have.
I was about to
excellent.
ask. I was going to say, is there a website somewhere like Alan's bookshelf that I can just go
My website had all that stuff, but again, it became to a matter of whether I could afford to run it now I'm retired. My wife, we're about to move to a little quiet Wiltshire village, and my wife said to me this morning, "About time you had a clear out in your office, isn't it?"
Hey, I call dibs. I know you're across the pond, but I'll pay the shipping if you have stuff that you're like, hey, I'm not going to throw this away, but this guy should read it. I call dibs.
I've got 400 books behind me.
It's probably cheaper for you to fly over and take it back on carry-on luggage, So,
well, not right now, but yeah, seriously though.
I've got a couple of hundred books behind me, and all the rest of it. It is a matter of. I was working for myself as a contractor in defense, and what I would do was take time out because somebody would say something and I'll go, I'll go and read about that. And it inevitably took me into all kinds of places and all kinds of things. The big, huge light bulb moment, without a doubt, was understanding the nature of cybernetics. And I met a guy electronically called Jeff Elliott on LinkedIn, who was such a godsend over the years, because he's somebody who knows about this stuff. There is an organization called Skyo, which I'll send you the link to. I can't recommend them too highly, because they've all got brains the size of a planet. They're all weird. But the things to do with the cybernetics is about the nature of communication. The leaders in it, or the pathfinders in it, as far as I'm concerned, are Claude Shannon and Turing. There just wasn't the words for it. Stafford Beer and so on. I can send you the list, and you can spend the next 20 years reading them, same as I did.
That's 20 years well spent, I think.
Yeah, if you whatever book lists that you'd like to send over to us, we're definitely going to publish them onto our website. So I think our audience would be greatly served by being exposed to the knowledge that we really should all have when we're dealing with designing systems. We should at least have some rudimentary knowledge of cybernetics, a rudimentary knowledge of how to design strong systems, no matter what role we're playing in the design, in the creation of them.
As far as I'm concerned, the failure to understand the nature of the system is writ large in the BA hack. It's writ large in SolarWinds. It's writ large in just about every single major hack you can see, because of the way people are doing things. They're just doing things I simply wouldn't countenance, not for a second. And it is a matter of, as far as I'm concerned, there has to be a change in mindset. And the change of mindset can only come at the moment, because it's taught, but not particularly well. Can only come by learning. But what it did for me anyway was made remarkable sense. So there's a guy called Ludwig von Bertalanffy, one of the sort of German scientists. He did some observations in his introduction to cybernetics, wrote about some observational experiments on a dog. Food in, mess out, and the way the dog grew its skin. And he came to the painfully obvious solution that the dog has just as much skin to cover the dog's body that it takes in through the food. Now, that sounds relatively simple, but when you think about it, to be able to prove it and all the rest of it demonstrates that the dog is a system. It's a living, breathing thing, and it moves around and all the rest of it. And it has a purpose and a design. Now, that's remarkable. Just on that one little thing, the way he describes it. Having said that, I've got a granddaughter, and I tried to explain it to her, and she looked at me like I was off the planet.
Yeah. So, Alan, we're out of time, but I feel like we could have a conversation for years about all of the vast knowledge that you've gathered over your career.
A week.
I do, yeah, a week. All right. Well, that's still a good amount of time. So, I hope you'd be interested in coming back on here, and we can further, explore the idea of cybernetics, further explore the ideas of designing strong systems, and talk a lot about the solutions that are involved there. But yeah, we're out of time here. Is there anything you would like to plug? Anything you'd like to?
No. The only thing I would say is this. I'm retired now, and as far as I'm concerned, this is me doing Waldorf impressions in the nicest possible way. It is a matter of, if anybody wants to contact him, send me a nag list of the things I promised I'd send, because I'll probably forget about it by the time I've finished. If anyone wants to chat through any of this, just give us a shout on LinkedIn.
Okay. All right, excellent. We'll put your LinkedIn link in the show notes for sure.
Yeah, okay. And it's been amazing, like seeing some of your posts on LinkedIn. I'm just like, wow, there's a lot here. It's like a little tiny, like a sampler. And then having you on the show is kind of like an appetizer. I don't think I really fully understand, but like it's amazing how much more detail in this form we're able to get. And I would really love to continue the conversation. And I feel like there's just so much more to be learned.
Well, that's kind. I mean, most of the time when I've been learning about this stuff, like I say, I have to pass the Sergeant Major test. And I have to go in and explain it to people who would probably eat me for breakfast if I didn't explain it the right way. But it is a matter of, when I was learning IT, I was taught to code in a way that was linear and what have you. And the world just isn't like that anymore. And I'm afraid there is a general failure to understand that, which is leading to the kind of loss of managerial control, which we're all seeing and suffering from now. I can't put it any other way.
Well, Alan, you gave us 5 minutes to get sick of you, and in an hour and 35, you haven't managed to do that. So I'm looking forward to having you back. So thank you very much.
Thank you.
Alan Woods, very, very eye-opening, very educational conversation. Much appreciated.
No worries. Take care.
Yeah, thank you very much. All right, folks, that's the end of this episode. However, we will be recording another one here in just about a little bit of time here. Today is a double feature, so we'll see how that goes. Alan Woods, again, thank you so much for coming on the show, and we're going to put all those citations, all of your LinkedIn links into the show notes, so everybody definitely check that out. And with that, Elio, anything that you want to sign off with?
No, that was fantastic. I can't wait to see part 2, part 3, and hopefully well beyond.
Awesome. All right, everybody, thank you very much for tuning in, and we will see you soon. Thanks.